four types of the formulas. Now, how do you represent? I said that regarding that urea, how do you represent it, right? There are different methods or different ways, right? The carbon compounds can be represented. So first way is a molecular formula. So like I'll start with the methane, a simple one, CH4. This is the molecular formula of methane. Like if I say ethanol, alcohol, right? The alcohol that people consume, ethanol. So C2H6, not H6. C2H5OH. This is the formula of ethanol, a molecular formula, ethanol, right? Sugar, when you ferment it, ethanol is formed, right? This bread, right? Bread, when you make, right, you add yeast to it. Yeast converts the sugar into alcohol. Ultimately, the dough becomes soft, the bread becomes soft when baked. So this is the molecular formula. Now, if I write down the structure, if I write down the structure of methane, the structure of methane would be like this. So once again, I would tell you that this is a planar structure, thus a structure to represent on the paper. Actually, how it is, that is a three-dimensional structure that we will see later on. Ethanol, if I draw the structure, it would be like two carbon we have. For this carbon, 3 valence is satisfied by the 3 hydrogen. For this carbon, one of the side has OH and the other side has the hydrogen. So this is the structural formula of ethanol. I'll teach you, right? You will also get to know how to write this. But preliminary, the first rule I said that if the carbon is there, it should have 4 valences. If one of the valences is shown, other 3 are not shown, you can write down hydrogen over there. If they are not shown, you can write down hydrogen over there. Then you have a condensed formula. So for this ethanol, if I write down, there is no condensed formula for methane, but for ethanol, if I write down, the condensed formula is something like this: CH3 CH2OH. See, this part is written, then this part is written, and then this part is written. So condensed formula, condensed form, you can say CH3 CH2OH. This is the formula of some another compound, right? If I name it, eth prop but pent. So this is pentane. Pentane is again a gas, a combustible gas, right? Butane is the gas that we use at our homes to cook food, right? Butane gas, Adani gas, the gas companies, they supply butane gas through the pipelines which we use to cook, right? Then line diagrams or line formula is also the way. For the ethanol, if I draw a line diagram, okay, yeah, it would be like this. So every edge will have a carbon. So here you have a carbon, here you also know this is wrong. So like this, and OH. So every edge will have carbon. Here you have a carbon, here also you have a carbon. And the preliminary rule, that tetravalency. So for this carbon, 2 bonds are satisfied, other 2 bonds you can show hydrogen attached to them. And for this carbon, one of the bond is satisfied, you can show other 3 hydrogen atoms attached to them. So you can just investigate C3, CH3, CH2 and OH. So this is a line diagram. So these are the ways through which you can represent a molecule. It depends upon what question it is or what is required. Sometimes it may be good to write a molecular formula. Sometimes it is good to write a structural formula. Sometimes condensed formula is also helpful, and many times line diagrams also help us to solve a question or to identify a compound. So these are the different notations. Once again, molecular formula. From the molecular formula, you have the structural formula. You should learn how to arrange them into structures, right? And then from the structure, you have condensed formula, and from the condensed formula, you have a line diagram. If any one of them is given, right? You should interconvert it. Let's try to interconvert all four of them for this one. What is this compound? So rule number one, that every edge has the carbon atom, right? So 1, 2, 3, 4, 5 carbon atoms, 5 edges. Preliminary rule, hydrogen atoms you should place if no bonds are free. So here no bonds, other bonds are shown. So by default one bond is here, so 3 hydrogen will be attached here, 3 hydrogen will be attached here, not 3, 2, because for this carbon we have one bond over here, other bond is over here. So 2 hydrogens, here also 2 hydrogens, here also 2 hydrogens, and for the last carbon there will be 3 hydrogens. So there was a line formula given, I converted into a condensed formula. Condensed formula, rather than writing this way, this is the how it is written: CH2, 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 and then CH3. So this is the line diagram converted into the condensed formula. Then you can convert it into the structural formula. This is exactly the structural formula. See, carbon number 1, 2, 3, 4, and 5. So first carbon has 3 hydrogen, 1, 2, 3. Second carbon has 2 hydrogen. Third one also has 2 hydrogen. The fourth one also has 2 hydrogen. Fifth one has 3 hydrogen. These are not placed randomly. The hydrogens are not placed randomly. As told you, the preliminary rule, that is the carbon is tetravalent. So 4 valencies must be satisfied. When one of the bond is shown, other bonds are not shown, you place hydrogen. For this carbon, 2 bonds are shown. Where are the 2 bonds? Place 2 hydrogens. For this carbon, one of the bond is shown here. Then where are the 3 other bonds? Place 3 hydrogens. For this carbon, 2 bonds are shown. Where are the 2 other bonds? Place 2 hydrogen. So this is how you interconvert from molecular to structural to condensed to line, or from line to condensed to structure to molecular, or from structure to condensed, structure to molecular. Any way you can do the conversions. Yeah, here these are some different notations. I told you that the structures that we have drawn here, these are just to represent on the paper. But how exactly those molecules look like, right? If I want to draw a human, like just a line diagram, I would draw like this. So it represents that this is some human being, right? If I draw like this, it represents that it is some animal, right? 4-legged animal. So this is just a planar representation, a line diagram. It's not exactly a human. Exactly humans look like this. So these molecules, exactly how do they look? So one we have methane. See this methane, right? No, it's not actually methane. It's just a carbon, and there are 4 different things attached to the carbon. What is this compound? This is a lactic acid. Lactic acid, it is an organic compound that is formed into your muscles. When you run and run and run and run very fast, right? The muscles below your knees, right? You feel pain in them. Why? It's because of lactic acid. So what is the formula of lactic acid? If I write down a molecular formula of the lactic acid, it would be like CH, then you have CH3. This is not the molecular formula, I am writing it down. You can say condensed formula. Then you have OH, and then you have COOH. So this is like the formula of lactic acid. 3-dimensionally, if I want to represent the lactic acid, right, it would be like this. You have this dark wedge, solid wedge, right? Solid wedge, this triangular type of thing, we call it as a wedge. Solid wedge means this hydrogen is coming outside the plane. You have just a dark line. So OH, it is just within this plane. COH, just a dark line. So COH is also within this plane. And then you have CH3, a dotted wedge. A dotted wedge, triangle, but in a dotted form. So it is on the back of this. So just try to visualize the 3-dimensional structure of the lactic acid. On plain paper, we may represent it like this, and this is a 3-dimensional notation. However, 3-dimensional notations are discussed at the PhD level, but just for the information. that whatever we write on the plain paper, right, and the three-dimensional structure, they are different. So this is a just example to show that how three-dimensional structures are represented. Important part is a solid wedge, which means coming out of the plane of the paper. Dotted wedge, going into the plane of the paper. Dark line, just a dark line, it means it is on the plane of the paper. This is some, yeah, this is the same structure. This is like Fisher projections. I'm not discussing it right now. Fisher projections, again a part of very higher studies. So this is how the molecules are represented, molecular structural condensed light diagrams, and then you have a three-dimensional notations. We call it as a Fisher projections also. Some Fisher projections, like see lactic acid, this is the molecular formula C3H6O3. Let's analyze. C3H6, what was it? C3H6O3. See, C1, 2 and 3C we have. 6H, 1, 2, 3 and 3, 6H. 3 oxygens, 1, 2 and 3 oxygens. So this is the molecular formula. What will be the condensed formula? Condensed formula, it's written over, this is a structural formula. Complete structure is shown. Structural formula means each and every bond should be clearly shown. That is a structural formula. You can see here. Structural formula. See, each and every bond is clearly shown. Structural formula. Then this is, you may take it as a condensed formula, right? CH, CH3, OH, COOH, and this is some three-dimensional representation, right? You see this is the carbon, right? This is another carbon, oxygen. This is red one is oxygen. This is also red one, oxygen, right? This is again a carbon, and on 3 dimensions we have hydrogen attached to it. Fisher projections, it gives us a 3-dimensional view of the molecule. However, not required as of now, but you can keep it for your knowledge, right? That apart from the molecular formula, structural formula, condensed formula, line diagram, there are also Fisher projections or Fisher formulas which exactly gives you the 3-dimensional structure of the compound.